We were talking about the Solow model without technological progress and population growth. We started off with the setup of the model, where we first discussed the production function. And here we talked about the assumptions that we make regarding the production function, where we talked about constant returns to scale. Then we talked about positive and decreasing marginal returns to both labor and capital. And then we talked about how we're assuming that there is no technological progress. Now we want to look at the investment output relationship in our setup. So here we're making three assumptions. First, we're assuming it's a closed economy, i.e. net exports are zero. This means that from chapter 3, investment is equal to private savings S plus public savings T minus G. The second assumption we make is that public saving is zero, which means that now investment is just equal to private savings. And then the third assumption we make is that private saving S is proportional to income, i.e. capital S is equal to small sy, where small s is our exogenous savings rate between 0 and 1. So given these three assumptions, the relationship between investment and output, once we introduce time indexes, as the time subscript allows us to be more specific about the timing of a variable, gives us. So basically, once we given these three assumptions and introducing time indexes, the relationship between investment and output is that investment is equal to private savings, which is proportional to income. So this means that investments come from savings and are some fraction of output. So overall, we can say investment is proportional to output. IT is equal to SYT. The higher output, the higher is saving and investment. So this is the investment output relationship under the three assumptions made in this chapter. So the key relationship here is that IT is equal to small SYT, where small s is your exogenous savings rate that lies between 0 and 1. Then let's talk about labor in our so basically, like we said, now we're looking at a setup. We discussed our production function. We talked about the investment output relationship. Now let's talk about labor. For simplicity, we're assuming that our labor input N is constant because right now we're looking at the Solow model without any population growth. So for now, we're assuming that LT is just equal to L bar. So then our production function with time subscripts is YT is equal to FKTL. Here we do not have a time index with L because we're assuming that L is constant, LT is just equal to L bar. So because we're assuming L is constant, we don't need a time index with it when we're writing our production function with time indexes. So for now, we're assuming that labor is constant when we're looking at the Solow model without population growth, but we'll relax this assumption later when we look at the Solow model with population growth. So the last thing in our setup we want to look at is the capital accumulation equation or the law of motion for capital. Now this determines the evolution of the capital stock over time. The basic idea here is that investment increases the capital stock and depreciation reduces the capital stock. Between two periods t and t plus 1, we can write change in capital stock as kt plus 1 minus kt is change in capital stock is equal to investment minus depreciation. Right, so this equation says that the change in capital stock is change in capital stock from period t to t plus 1 is equal to investment during period t minus depreciation during period t, where delta is your depreciation rate, is a constant depreciation rate between 0 and 1. We can also rearrange the above equation in a different form, right? So here we have written the capital accumulation equation as change in capital is equal to investment minus depreciation. We can also rewrite it in a slightly different form where we write it as KT plus 1, like making KT plus 1 the subject. So over here we can say that the capital next period, T plus 1 is equal to undepreciated capital from the previous period, i.e. from period T plus investment. So the capital accumulation equation can either be written as change in capital is equal to investment minus depreciation, or it can also be written as capital next period is equal to undepreciated capital from the previous period because delta is the depreciation rate. So 1 minus delta gives us the undepreciated capital plus investment. So this is our setup where we looked at the production function, we looked at the investment output relationship, we looked at labor, and then we looked at the capital accumulation.